Hi, my name is Zio. I'm doing my TSAL assignment presentation part 1. So the aim of this presentation is actually to find out how a particular brand um, actually have a positive or negative uh, effect on the public. So we'll be using tweets from Twitter to actually help us understand more about it. So the brand I've chose is called Chevrolet. So these codes over here, I'm actually creating a folder into the C drive called the TSAL to set a variables to capture the path in it. And this code here is actually used to specify the path into a desired folder I want. In this case, is called path. So all these packages over here are I'm actually installing them. Uh, I'm actually installing them from the internet, which is open up to public. And in order to use the packages I downloaded above, I need to write in these codes called the library and the name of the packages to load it inside the RStudio before I can use them. These keys were obtained from the Twitter application app to verify my account so that in the future I'm able to use this Twitter account for my analysis. This line of code below helped me finalize my keys into the R system and actually set up my account. I'm creating a list to capture the result I got from Twitter. So in this case, I am searching for hashtag Chevrolet, and the N represents the number of tweets I wish to obtain. However, since this is a non-paid application, the result I obtain in the end may not be 5,000, it may be lesser. And this length function is set to English so that the result I obtain will only be in English character. These codes will help me convert the result I obtained into a data frame and read it into a CSV file. So earlier on, I created a path called TSL in my C drive. This CSV file will be placed over there. The codes below allows me to have a closer look of the tweet. So this code actually represents the number 8 tweet of the result I captured from Twitter, and I'm able to view them in a better view. So as you can see over here, this this is the number 8 tweet I gotten from Twitter, and the screen name of the person is actually called, this is the name of the person. Next, the air supply function is used to apply the accessor in RStudio. So, and the get text function is actually to retrieve the tweet by rows in the tweet list. So this code over here will help me to build a corpus, which is a collection of text document, so that we can use it. We can use tag mining technique to actually clean up the tweets for further analysis. These two lines of code actually help me remove the punctuations and convert text to lower cases of the tweets I obtained earlier on. This function below help me identify all the stock English stock words such as the is, the, they are, and many more. And alternatively, we can also add in words that we do not wish to see, such as love, beauty, sales, size, massive, and the others. Lastly, this code will help me plot a word cloud in RStudio. This is the word cloud. We can see words such as Chevrolet, which is the brand. We can see words such as Chevy, which is one of the model of the brand under Chevrolet. This code over here help me generate a terms document matrix for my Chevrolet, and actually it identify those with frequency that are greater than 100. These are some example of words that are frequent terms that is used as more than 100. There are car, truck, Silverado, which is another brand of Chevrolet. This code here help me generate a dendrogram. It will remove terms that are sparse and only keep 5% of the top appearing terms and convert them into a data frame. So 5% is represent as 0.95 over here, and this code over here will help me identify 5 clusters and group them up. So this is the dendrogram that we created. There is 5 sections. When terms are grouped into one cluster, means that they are more associated with one another. So we can see that cars and Sherry is actually more associated to each other as compared to others. These codes here actually help me classify the tweets based on their emotion as well as their polarity, visualized using plots. So there are some polarity or there are some emotions that can be unknown from the tweets. So those unknown emotions are actually named as rejected. Next is this code over here. It classify the polarity. These codes here actually create a data frame containing all the tweets, emotion, and polarities. This code here is they sort the data frame based on the frequency for emotion in the ascending order, and they will plot out the emotion graph, which I will talk about more in the part 2 of my video. This code here is also plotting another graph, which is the polarity graph, and I will talk about more about these two graphs in the next video. This whole chunk of code over here is actually a function below. It's a function to compare each tweet against a collection of positive and negative words. So each time a match is found, it adds to the count. The final score of the tweet is equals to the positive words max count minus of the negative words max count. So hence, if a tweet that has a greater score than 0 means that it contains more positive words than negative words. This tweet here is actually I'm loading the sentiment word list into RStudio. We also can add in negative words into the list that we do not wish to see. This code here is we are actually importing the previous score files into RStudio, and this code help us to score all the several tweets we obtain. Then this code here is to help us export this score out into a CSV file located in this path. This code here is actually plotting the graph legend such as the x-axis and y-axis. I will show more of the graph in the later part of the video in part 2. And lastly, these two codes over here, it creates a table of counts of scores for Chevrolet, and there will be a graph for it also. I will show you at the part 2 of the video. So I've come to the end of the part 1 of my presentation. Thank you.